So this is the 2012 AP Calculus exam, and problem 5 was the same on both the AB and BC exams. We're given a differential equation here and an initial condition, and I should be more precise on that initial condition. This is T and this is B. And then later on in the problem we're going to be given a graph, although curiously enough this graph, it says, is not B of t. So just keep in mind that the graph we're looking at is not B of t. We're going to be asked to show why we know that. Okay? So our first question is whether the weight gain, and W of t is the weight, whether the weight gain is faster when the bird weighs 40 grams or when it weighs 70 grams. Well, look, we can see that dB dt at when b equals 40, okay, is equal to 1/5 100 minus 40, okay, and dB dt when b equals 70 equals 1/5 of 100 minus 70. Okay, so this of course is 60. 1/5 of 60 is 12. This is 30. 1/5 of 30 is 6. And so it is here at b equals 40 that the weight gain is faster. I guess we'll call it the rate of weight gain is greater at 40 than 70. All right, now we have to find the second derivative of b with respect to t. That's what part b is asking, dtb, dt2. Well, that's going to be the derivative with respect to time of the function that they already gave us, db dt. Or in other words, the derivative with respect to time of 1/5 of 100 minus b. Taking that derivative is straightforward. The first term is going to be 0, the derivative of a constant, and the second term is going to be negative 1/5 dB dt, but we already know that dB dt itself is 1/5 of 100 minus b, and so we can finally conclude that it equals, this continues from over here, negative 1/25 negative 1/25, I'm blanking out. And so this equals negative 1/25 of 100 minus b. Now, why is it that our calculation tells us that this cannot be the graph of b? Well, we've just found the second derivative of b. That's the concavity. The concavity here, as long as b is less than 100, the concavity is negative. Okay? And yet it's apparent that at the start of this curve, the concavity is positive. Okay? So, this implies negative concavity. For whenever b is less than 100, but graph has a region of positive concavity. Which contradicts. Okay, finally, we'll use separation of variables to handle part C. We have dB dt equals 1/5 100 minus b. We separate the variables. We get dB over 100 minus b equals 1/5 dt. We perform the integration on both sides. This side is straightforward. We get 1/5 t plus a constant. This side requires a u substitution. I'm just going to write the u substitution up here. The u substitution is u equals 100 minus b. Therefore, du dB equals -1. So now we perform that u substitution. We got du over u negative. Okay? We get negative ln of the absolute value. Instead of u, I'm going to rewrite 100 minus b, and that equals 1/5 t plus c, where we've consolidated any unknown c from this side over into this constant. We'll move the negative sign over to the other side of the equation and then exponentiate both sides to get 100 minus b absolute value equals e to the c, e to the -1/5 t. I've changed c to -c here, but we continue to change c until we get it into the position we want, just because I moved the negative sign over. Now, to get rid of this absolute value sign requires us to write that this equals plus or minus e to the c, e to the -1/5 t. And now it's time for us to use our initial condition. This whole quantity here is what we don't know. We don't know whether the sign is plus or minus, and we don't know c. So this entire quantity is what we're going to solve for. And so we plug in the initial condition, namely that 100 minus 20 equals 80 e to the 0. And therefore, this coefficient in front of the e to the -1/5 t is 80. That helps us deal with the plus or the minus sign. And so finally, we can write that 100 minus b equals 80 e to the -1/5 t. Or we can say, rearranging, b equals 100 minus 80 e to the -1/5 t.